Good day, learners! Are you ready to have fun with math? How do you feel today? I hope you are all okay. I am your teacher Anne, and let's make learning more fun. Before we start, here are some reminders to keep in mind. Number 1. Stay alert and focus to the video lesson. Number 2. Prepare your pen and paper for your answer sheets. Number 3. Sit back and relax as we enjoy our learning for today.
For today's lesson, we're going to describe the roots of the quadratic equations by using discriminant. In the quadratic formula, x is equal to negative b plus minus the square root of b squared minus 4ac over 2a. The radicand b squared minus 4ac is called the discriminant. From this, we can conclude in general that a quadratic equation has two solutions called roots of the quadratic equation. And then, in this discriminant, we're going to also find the value of a, b, and c. An examination of the roots will show that the nature of the roots can be decided by the value of b squared minus 4ac in the equation ax squared plus bx plus c is equal to 0. The roots of a quadratic equation can be rational, irrational, real, and imaginary numbers. When the discriminant is 0, there is one repeated solution, and it is a real and equal numbers. Whenever the discriminant is positive, there will be two different real number solutions. When the discriminant is positive and the perfect is square, these solutions will be rational numbers. When the discriminant is positive and not a perfect square, there will be two irrational solutions that are conjugates of each other. And when the discriminant is negative, there will be two imaginary number solutions and they will be complex conjugates of each other, meaning there are no real roots or solution. To further analyze it, let's have an example. Let's find the nature of the roots of x squared minus 6x plus 9 is equal to 0. The equation gives a is equal to 1, b is equal to negative 6, and c is equal to 9. Substituting the given values of a, b, and c in the expression b squared minus 4ac, we will be having b, which is negative 6 squared minus 4 multiplied by the value of a, which is 1, and then multiplied by the value of c, which is 9. And then perform the operation. We will be having negative 6 squared is 36 minus 4 multiplied by 1 is 4 times 9, which is 36. So 36 minus 36, that is 0. If our discriminant is 0, what will be the nature of our roots? Our roots are real numbers and equal. Let us check. How are we going to check if our answer is correct? Let's use the quadratic formula. We're going to substitute the given values of a, b, and c to the given quadratic formula. We will be having negative multiplied by the value of b, which is negative 6, plus minus the square root of negative 6 is squared minus 4 multiplied by the value of a, which is 1, multiplied by the value of c, which is 9, over 2 multiplied by a, which is 1. And then perform the operation. We will be having negative times negative 6, which is 6, plus minus negative 6 squared is 36, minus 4 multiplied by 1 is 4 times 9, which is 36, minus 36, over 2 multiplied by 1, which is 2. And then simplify the square root of 36 minus 36, we will be having a square root of 0, or that is 0. Therefore, we will have 6 plus minus 0 over 2. And then separate the two operations. We will be having 6 plus 0 over 2, or that is 3. And the second one is 6 minus 0 over 2, which is also 3. Therefore, the roots of x squared minus 6x plus 9 are real numbers and equal. As you can see, they are both 3. Let's have another example. Find the nature of the roots x squared minus 2x minus 3 is equal to 0. The equation gives a is equal to 1, b is equal to negative 2, and c is equal to negative 3. Substituting the given values of a, b, and c in the expression b squared minus 4ac, we have the value of b, which is negative 2 squared, minus 4 multiplied by the value of a, which is 1, multiplied by the value of c, which is negative 3, and then perform the operation. We will be having negative 2 squared is 4, minus 4 multiplied by 1 is 4, multiplied by negative 3 is negative 12. Therefore, negative multiplied by negative 12, that will become positive 12. So 4 plus 12 is 16. Therefore, if our discriminant is 16, what will be the nature of our roots? Since 16 is a positive real number and 16 is a perfect square, therefore, the roots are rational numbers and not equal. Let us check. By using the quadratic formula, let's substitute the given values of a, b, and c to it. We will be having negative multiplied by negative 2 plus minus square root of negative 2 squared minus 4 multiplied by 1 multiplied by negative 3 over 2 multiplied by 1. And then perform the operation. We will be having 2 plus minus square root of 4 plus 12 over 2. And then simplify square root of 4 plus 12, which is the square root of 16, or that is 4. Therefore, we will be having 2 plus minus 4 over 2. And then separate the two operations. We will have 2 plus 4 over 2, or that is 3. And then we also have 2 minus 4 over 2, and that is negative 1. As you can see, the roots of x squared minus 2x minus 3 is equal to 0 are 3 and negative 1, which are rational numbers and not equal. Therefore, our answer is correct. Let's have another example. Find the nature of the roots x squared plus 5x plus 3 is equal to 0. The equation gives a is equal to 1, b is equal to 5, and c is equal to 3. Substituting the given values of a, b, and c in the expression b squared minus 4ac, we have the value of b, which is 5 squared, minus 4 multiplied by the value of a, which is 1, multiplied by the value of c, which is 3. And then perform the operation. We will have 5 squared is 25 minus 4 multiplied by 1 is 4 multiplied by 3 is 12. So 25 minus 12, we will have 13. Since 13 is a positive number and 13 is not a perfect square, therefore the roots are irrational numbers and not equal. Let us check if our answer is correct. By using the quadratic formula, let's substitute the given values of a, b, and c to the given formula. We will have negative 5 plus minus square root of 5 squared minus 4 multiplied by 1 multiplied by 3 over 2 multiplied by 1. And then perform the operation. We will have negative 5 plus minus square root of 25 minus 12 over 2. Let's simplify square root of 25 minus 12, which is the square root of 13. So we will have negative 5 plus minus the square root of 13 over 2. And then separate the two operations. We will have negative 5 plus the square root of 13 over 2 and negative 5 minus the square root of 13 over 2. Therefore, the roots of x squared plus 5x plus 3 are irrational numbers and not equal. Therefore, our answer is correct. Let's have the last example. Find the nature of the roots of x squared minus x plus 2 is equal to 0. The equation gives a is equal to 1, b is equal to negative 1, and c is equal to 2. Substituting the given values of a, b, and c in the expression b squared minus 4ac, we will have the value of b, which is negative 1 squared, minus 4 multiplied by the value of a, which is 1, multiplied by the value of c, which is 2. And then perform the operation. We will be having negative 1 squared is 1, minus 4 times 1 is 4, times 2 is 8. So 1 minus 8 is negative 7. Therefore, if our discriminant is a negative number, our roots is imaginary number, or there are no real roots or solution. Let us check if our answer is correct. By using the quadratic formula, we're going to substitute the given values of a, b, and c. We will have negative multiplied by negative 1 plus minus square root of negative 1 squared minus 4 multiplied by 1 multiplied by 2 over 2 multiplied by 1. We will have 1 plus minus square root of 1 minus 8 over 2. And then simplify square root of 1 minus 8. We will be having square root of negative 7. Therefore, we have 1 plus minus square root of negative 7 over 2. And then separate the two operations. We will have 1 plus square root of 7i over 2, since the square root of negative 7 is an imaginary number. And the second one, we will have 1 minus the square root of 7i over 2, which is also an imaginary number. Therefore, there are no real roots or solution in a given quadratic equation, which is x squared minus x plus 2 is equal to 0. And those are the nature of the roots by using the discriminant. To summarize, the value of b squared minus 4ac is called the discriminant. The roots of a quadratic equation can be described by using the discriminant even without solving for the value of roots. And there are four natures of the roots of a quadratic equation. Number 1, if the discriminant is 0, then the roots are equal and rational. If the discriminant is positive and a perfect square, then there are two unequal roots which are rational. If the discriminant is positive and not a perfect square, then there are two unequal roots which are irrational. If the discriminant is negative, then there are two unequal roots which are not real numbers, meaning there are no solution. I hope you understand our topic for today, learners. Those are the four natures of the roots of a quadratic equation that you need to remember. So that's the end of our lesson for today. Thank you for watching.